The average acceleration between time t1 and time t2 would then be the velocity at time t2 minus the velocity at time t1 divided by t2 minus t1, and the dimension is lengths per second per time squared, so it's meters per second squared. This is then for a one-dimensional situation. This number can be larger than 0, it can be equal to 0, and it can be smaller than 0. In our case, t1 to t2, here, notice the velocity is 0 as a start, and it begins to increase because this angle of alpha increases. It's the angle that matters. The angle increases, so in our case, from t1 to t2, the average acceleration is larger than 0. Look at the angle. However, if you take the average acceleration between t1 and t5, that is smaller than 0. Because here, the velocity is 0. But here, the velocity is negative. So if you substitute that in there, you get an average acceleration which is smaller than 0. So the signs in the velocity and the signs in average acceleration depend crucially on how I have defined my increasing value of x, not where I choose my 0 point. If I reverse the direction of increasing x, then all my signs will change. So you can also write down then that average acceleration, if you like that, is delta v divided by delta t, but you must be careful because the delta v is sign sensitive. You must obey your sign convention.